In this part of the chapter, we will be discussing some simple algorithms that are used extensively in numerical computations in science and engineering. Increment loops. As their name suggests, they are based on the increment operators and used to store data incrementally as the loop advances. They can be used in both for and while loops. The first one is the counter. It simply counts the number of cycles in a loop or the number of executions of a specific statement inside a loop. It has two components: the definition, which is usually 0, and it must be located just before the loop. The second component is the increment statement, which is located inside the loop and directly precedes or follows the operation that is to be counted. Counters always increase by 1. In this code, the counter stores how many iterations until x reaches the value that ends the loop. In other words, the value which makes the looping condition false. So as we see here, it took 5 steps to end the loop and print the final result. We can define the summation algorithm as the general case of counters. The main difference is that while in counters the value of increment is always 1, in summation the increment has different values. They could be float or integer, and they are calculated inside the loop and added to each other through the summation operation. The terms of the summation could be calculated in multiple operations, and the summation value could be used in proceeding operations inside or outside the loop. Another difference from the counter is that summation could start with any initial value, including 0. In example 1, we have this summation formula, and the value of x is 0.5. Let's define the value of x. S can start here with the initial value of pi, 3.14. Since it is counted loop, because we have values of I, we can use for loop for I in range from 0 to 11. Again, remember that range always stops one value before the stop value. Now we calculate each term. So let's say t equals to x plus I to the power 2. Then the increment operator. Finally, we can print each value of s to check the progress of the code. Okay, so as we see here, this is the result. So there's an obvious increment. It's better to print out the value outside the loop. We shift this print to the left. Let's test again, and we get the final value. Now, the question is, what if there's no pi? The answer is very simple. In this case, s equals to 0, and we can run the code. This Fibonacci sequence is a sequence that the sum of each two numbers gives the third number. For example, 0 plus 1 equals to 1, 1 plus 1 equals to 2, 1 plus 2, 3, 2 plus 3, 5, and so on. The algorithm that I'm going to use here has two variables, j and k, added to each other alternately in a counting loop. So first we define the first two integers in the sequence. Then we start a for loop that counts 5 repetitions. And why 5? Because we already have the first 2, so that means in this loop we need 10 more terms. And since the loop computes 2 values every cycle, so we need 5 cycles in order to get 10 more terms. The next term will be j, k. In other words, actually we are moving through the sequence as jk, 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 and so on. Then we print the value. Next, we compute k, and then print k. Now let's run the code. So in order to add the first two terms. Okay. Product algorithm is very similar to summations 1. The only difference is that the operation is multiplication. The initial value could be any number except 0, since it will always result in 0. Like summation, the terms of product could be calculated in multiple operations, and the product value could be used in proceeding operations inside or outside the loop. In example 1, we are going to write a simple program of factorials. Since the number of terms is not given, we can define it by using input function. The initial value of the factorial variable must be 1 in this case. Since we have a specified numeric sequence 1, 2, 3 to n, we use for loop within the range of 2 to n plus 1. Now we add the second component. Finally, after the end of the loop, we can print So let's try to run the code. Let's say n equals 3, just simple test. Let's try another number. So it works in this way.